Or all right, welcome everyone. This presentation is being recorded. Please mute your mic and turn off your video during the presentation. If you have a question or you need clarification on anything during the workshop, please type it in the chat. And after today's presentation, a copy of the slideshow and a video of today's workshop will be available on the gsdscf.org website. Let's get started with some SLB introductions. So my name is Stephen. I'm in 10th grade, and this is my fourth year competing in the GSD-SCF. Alex, I'll pass it off to you.
Hello, my name is Alexander Allport, and this is my third year competing in the GSD-SCF. I'll pass it on to Charlie.
Hello, I'm Charlie, and this is my second year competing in the competition.
All right, thank you all. So our general agenda for today, today's workshop is going to be on basic data analysis. So we'll be going over what exactly is data analysis and why we use it in projects. Also, we'll be talking about the importance of using the right type of graph or analysis for a certain project. And then we'll go over what are the important parts of good figures and how to talk about them. And we'll wrap up with a few graphing demonstrations. All right, some PSAs just ahead of time. Our next workshop, which is the second part of this series on data analysis, is going to be about more advanced forms of data analysis. It's going to be on Saturday, December 20th. So please keep your eyes peeled for that. Also, I'm sure you all are working on your projects pretty hard right now. We have our 2026 quality screening deadlines. This is sort of like SRC, where you just submit a portion of your project to a screening committee, and they just make sure if you're like on the right track, if you're following the proper scientific procedures. So all the dates on here should cover all types of projects through 6th through 12th grade. And as always, fair updates are on our website. You can follow our Instagram for updates and new workshops. And our YouTube channel contains all workshop replays, as well as instructional videos for safety and screening and applications.
Yeah, so right now we're trying to structure our workshops to better prepare students to write their project notebooks. So if you have any questions about the fair format this year, just visit our website, ask in the chat or in the breakout room today. So last workshop, we covered how to make an introduction, a hypothesis, a problem statement, our materials list, and the methods of your report. Click. And then this workshop will then teach us how to make our results and data and our data analysis. And next workshop will be finishing our project with a conclusion, appendix, and abstract, which we'll write last, but will actually be at the beginning of our lab notebook. So we highly recommend that you stick to this structure, and you can find a sample on our website. Cool. So remember in the organization to organize all of our numerical data in our tables. And we recommend using Excel and Google Sheets as they have some good features of graphing our data. And we should be keeping our photos and observations neatly so that later in time we can easily refer and compare them. And all of these can go into your appendix. So we're going to want to make our notebook nice and neat. And even if you think that some data or pre-trials is useless, you may want it later, and it's better to just be safe than sorry. Cool. So first, in analyzing our data, we're going to want to organize our data neatly and graph out the values. Next, we're going to want to observe your graphs and calculate some general statistical values such as mean, median, and mode. And lastly, we're going to want to discuss what our graphs tell me about what the project is. Cool. So what makes a figure graph good? Well, I have some bad examples right here. So for example, in the first most leftmost table, we might ask what kind of trends are happening, which cost is related to another, and it may be difficult to tell which um, which one is dependent on the other. In the bottom right graph, we might ask, okay, well, what percentage of people scored higher than 2? Just looking at the data here, it may be difficult to answer these questions. So we're going to want to turn them into better tables so that we can better understand this. So the first step in making a good table is labeling our table. Oh, next slide. So in this table, you can't really tell what any of the numbers actually mean because there aren't any labels. So we're going to want to add some titles that are actually describe what the numbers mean. We're gonna want to add proper units because we don't know what units the numbers are in. And we're going to want to add appropriate decimals because money is measured in the hundredth place. So we're going to want to add that. Cool. Second, in our graph, we're going to want to label both of our axis and our lines. Here we have just 2 blue lines. We don't know what each means and, which is which. So first, we're going to want to add a descriptive caption and title. Second, we're going to want to add a legend. Legend, and see how we color coded it so that we know what each line is meaning. So the blue one is species 1, the red one is species 2. So different colors. Third, we're going to want to label our axis with units. And fourth, we're going to want to make sure that our axes are uniformly spaced, because if they're not evenly spaced, then we don't know how much a distance means. So in this case, like 1 box is 2 hours.
All right, Alex, I think you can take it away from Q.
Sorry, I was muted. So now after that, we'll be doing a few exercises where we'll be exploring tables and graphs. So first of all, here's the first chart where we have temperature and cost of 3 things. So what kind of graph is this? So the one way to graph this could be like a line graph, which we have on the right. And one example, like to interpret this, would be as in temperature rises, ice cream sales rise. Because as you can see, ice cream sales, which is represented in blue, have gone up while temperature has increased. You could also interpret this as hot cocoa decreases in sales as temperature increases, because hot cocoa is represented by the red line, and as the red line goes down, we can interpret it as hot cocoa sales decrease. And then lastly, cake sales seem to be independent because, like, while they do go up and down, they don't really have any major shifts that would be able to that wouldn't be able to be considered a large shift. So the independent variable, first of all, is the independent variable is the variable that isn't really dependent on the other one, I guess. Like the 10, 15, 20, and 25 and 30 degrees temperature in Celsius is the independent because it doesn't rely on the number of sales to change temperature, right? But the ice cream store sales do have a change in sales with a change of temperature. Okay, moving on. So next we have like a species and time. What kind of graph would this be? Well, once again, it would either be like a scatter plot or a line graph. I personally would put a line graph just to show the connection, and on here it's also a line graph. Line graphs are with discrete points, which pretty much just means like there's definitive points. It's mostly used for change over time. And so this graph is useful when you have individual data points, especially plotting change over time. The results statement could be that, or the interpretation could be that species 1 had exponential growth and it surpassed at approximately 10.5 hours because you can read off the graph. Moving on. Here's another table graph. While this one couldn't be a line graph since you can't really number the types of classes. There are multiple categories paired with numbers here, which is why a bar graph would suit it best. Bar graphs are good for categories, frequencies, and percentages. And so one interpretation here is algebra and physics are the most popular subjects, composing about 10% of all students. Yeah, moving on. And last but not least, we have a small table here, but it's with percentages. While I did say on the previous slide that bar graphs are good for percentages, this one would be better to use a pie chart, because it has percentages for fewer categories. In addition, percentages by definition are parts of a whole, which are represented with a pie chart. So binary data is also best represented by a pie chart. One type of binary data is a yes or no, because that typically has a percentage, like 60% of students voted yes, 40% of students voted no. And so here we can look at 51% ranked it as a 2 or below, because if you look, 2 has 12%, 1 has 3%, and 0 has 36%, and so that combined is 51%. Most frequent response was 0 because you can just look, first of all, by 0 is obviously the biggest one, but it also does have exact numbers with 36%. So there are a few other types of graphs. These are a bit less common, but they're just as useful. If you don't think your data will fit any of these, at the end we will have a Q&A and you can ask us about these types of graphs. And yeah. Okay, so to review mathematical values that most students use to summarize the data, we're now going to briefly go over how to calculate an average. First of all, the average is hold on, I lost it, is it's like the mean. So if we take the class data and we want to know the average number of students per subject, we could take the total number of students, which is, if we do that, it is 405. And then since there are 12 classes, you can divide it by 12. And then with that little math, we get the average of 33.75 students per class, or 34 students. Yeah. This is the mathematical formula for a average sum of values over sum of numbers. Okay, for percentage data, we wanted to find what percent of students take Spanish during this period. So, what we do is number of students in Spanish, which is 44, over total number of students, which is 405. We get 0.11, but since it's a percentage, we multiply it by 100, and that's 0.11 times 100 will get you 11% of students are taking Spanish. During the breakout sessions, if we do them, I don't know if we will be doing them, we can go over how to calculate these in Google Sheets and Excel. It's not that difficult, yeah.
Okay, thank you, Alex. And just a heads up to everyone, this meeting does have a 40-minute time limit, so I don't think today we can get into breakout rooms, but we will be able to do a Q&A session afterwards, hopefully with this meeting, but if not, we will use a new link. So please keep your heads up for that. And now let's go on to summarizing and interpreting your results. So beforehand, you learned how to use some really excellent data analysis data analysis techniques. So now how should you talk about this? In science, it's pretty important to understand the difference between your results and your discussion, even though they go hand in hand. So your results will only be the facts that describe your charts, and it's likely just numerical aspects of the data, like 54%, 51 students, etc. However, your discussion expands upon your results, and it allows you to interpret them in the context of both your prior research and your opinions. You can attempt to explain why something happened the way it did, or what an outlier may mean. And in addition, you should connect your results to your hypothesis and explain how it supports or rejects your initial predictions. Like we've been speaking about, your results are about identifying what's going on in your data. So the following values like mean, median, mode, standard deviation, standard area, can be useful in summarizing a general trend that's happening across your experiments. And please remember to compare across trials for precision and contrast various conditions to investigate your hypothesis, which I'm sure all of you are doing in your wonderful science projects. So, and then to put together the results, you just review your data first. So you look at it with a critical eye. And there's a few questions that you should be asking yourself, like, do you have enough data, first of all? If you're trying to do a representative sample of your school and you just pick 3 people, that's obviously not a representative sample of your school, right? So you would need to get more people or something like that. Or what information does the data collected tell you? What trends or patterns do you see? Did you get the results you expected? All of this makes a great review analysis. And then you, to summarize the results in your discussion, or not in your discussion, this is just the results. You would use objective observations, right? So no opinions, without using the word I. And if something happened that you didn't expect, you should make sure to highlight it. And within your claims, you should use your calculations and data to support them. So either the hypothesis you created at the beginning of your project, you can use data to support it, or you can show how the data contradicted the hypothesis. And that's still a really good science project either way. Here are just a few example statements used to summarize your results. And notice how none of these are like objective. They don't have any opinions. So all of these statements are just completely factual. There is no personal bias. It's like the most or least frequent response was. It's not giving a reason why, it's just stating that it was. And please use units of measures in your statements as appropriate. And then in your science notebook, you'll be summarizing your results in writing. So if we take a look at these sentences, you can expand on these a bit, like the examples that you can see here. For example, the most frequent response for 30 fifth grade students was 3 hours per day for TV viewing with an average of 2.8 hours. So notice that number one is completely objective. Number two, all the units are present. And number three, the sample size is good. And they included the numerical data of the average. This is a very good summary statement of your results. Well, this concludes the workshop segment. So we'd like to thank you once again for coming. We do apologize about the delay at the beginning. We hope that won't happen again. And in the future, our next workshop, the second part of this series on data analysis, will be on December 20th. So make sure to attend that workshop if you want to see more advanced methods of data analysis. I know a lot of you out there are probably doing machine learning projects, so we'll be going over a few things relevant to those projects like chaos plots, as well as just more in-depth analysis of your data. As always, if you have questions, you can email the GSDSEF SLB. And if you are interested in joining our mentorship program, you can sign up with this link. I'll be releasing the slides onto the website, and I'll also be releasing it into the chat afterwards. And this will conclude the recording.